Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we are going to talk about both the distance and the midpoint formula. These are two formulas that, once you know them, they can make problems quite easy. And if you don't know them, then a simple problem can seem rather difficult. This does have, or rather the distance formula does have some key ties to the Pythagorean theorem, which is the lesson that we talked about in our last video. So keep an eye out for where you might see the Pythagorean theorem today. But other than that, let's jump right in. So what you're going to do, and if you want to, you can pause the video right now and you can try to work through these 6 questions. These are the questions that are going to help us derive the distance formula. A lot of times with specific formulas, I don't like to just give them to you and say, memorize this. Memorize the formula for the area of a triangle or for the volume of a sphere, etc., or the distance formula. If you have an idea of how those formulas came about and why they're put together in certain ways, then a lot of times you're more likely to remember them rather than just, trying to remember a random string of letters and numbers. So hopefully this little activity shows you where the distance formula comes from, which will make it a little bit easier to remember. All right, so our goal is going to be to write an expression for the distance between these 2 points we currently have labeled on the graph, x1, y1, and x2, y2. You probably already know how to find the distance if we're just talking about a single number line, right? If I just have a number line and I have 2 points plotted, 4 and 13, you could probably pretty easily find the distance between those. We'll talk about that in just a minute or two. But today we're going to work out a formula for when the points are not either both on the y-axis, so they're not both vertically one above the other, or when they're not both on the same horizontal line. All right, so we have to factor in both the x-axis and the y-axis here. So we're just going to walk through these steps. If you want to, I would encourage you to pause the video and try to get through as many of these as you can. The first 1 to 3 are actually pretty straightforward, so you could do without having to think too hard. Number 4, 5, and 6, that's where the real work comes in deriving this distance formula. Okay, number 1 says, graph the point x2, y1. So I'm going to come to my graph, go over to x2 on the x-axis, go up to y1 on the y, and there's that point. x2, we'll even label it, x2, comma y1. Done with number 1. We'll get rid of this number line for now. Number 2 says connect the points to form a right triangle. Again, that's straightforward enough. Put my right angle there. It says label the hypotenuse as D. So I'm going to find my right angle, go straight across. The opposite side will be our hypotenuse, which we'll call D. And we're off to number 4. It says write an expression for the length of the base of the triangle in terms of x1 and x2. So because the x and y axis are not labeled with actual numbers, we can't find a number length, but we can have an expression for the length. So this is what I was talking about before. If I just gave you an x-axis, right, so I'll just say our x-axis looks like this, and we'll actually use numbers here first. So let's say I'm at 1 and I'm at 8. I think we could all figure out what this distance has to be, right? So obviously we would subtract 1 from 8, so the length of the distance is equal to 8 minus 1, which is equal to 7. So if I relate that to my x2 and my x1, well, I'm going to subtract the x value that's the smaller x value, the one that's less than the other one, from the initial one. So I'm going to have x2 minus x1. Right? And if we relate that to what's over here, that would be 8 minus 1. I just don't have any numbers on the graph that I'm given. Okay, let's do number 5. It says write an expression for the height of the triangle in terms of y1 and y2. So same concept applies. If I have a y-axis, right, and let's say I'm at 1 and 8, well, this length, right, would be equal to 8 minus 1, the smaller value subtracted from the larger value. So if I just have y2 and y1, well, I'm going to have y2 minus y1. So now I have expressions for all three sides of my right triangle. I have an expression for the base in terms of my x's. I have an expression for the height, or the other leg, in terms of my y's. And I have an expression for the hypotenuse. We're just calling that d. So now if I have expressions for all of the sides, I can set up a Pythagorean theorem equation. I'm not going to scroll down because I don't want to lose the diagram I have. What I'm going to do is do the work over here on the right-hand side. So remember, if we set this up, we have a squared plus b squared equals c squared. And remember, the a and the b represent the legs, and c represents the hypotenuse. So let's do some substitution. Well, for one of my legs, I have x2 minus x1 quantity squared. For my other leg, I have y2 minus y1 quantity squared. And for my hypotenuse, that is d, so d squared. Well, if I want to find the length of the hypotenuse, right? If I want to solve for d to get d by itself, because remember, our hypotenuse here is the distance. That was the distance we're looking for, right, between those 2 points. So I want my formula to tell me what the distance is between those two initial points, which means I need to get d by itself. So I'm just going to take the square root of both sides. So that's going to give me the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared is equal to d. And you could switch that around, right? It doesn't matter which side my d is on. You're generally going to see the equation written like this. Of course, it means the same thing. And this right here is the distance formula. So it looks pretty complicated, right? If I just showed you what that formula was, you wouldn't really understand, well, what's going on there? What are those x's? What are those y's, etc. But hopefully with the diagram and talking through how it's related to the Pythagorean theorem, because it's really just a Pythagorean theorem equation, right? Just solved for the hypotenuse. Hopefully talking through that helps you understand where this comes from and will hopefully help you remember it down the road. Let's now work at applying this formula to actually find different distances. So I'm going to clear this. We're going to do number 1, and we will also do number 7, possibly. We'll see. So pause the video, attempt number 1 and number 7, and then we will review. All right, so number 1's pretty straightforward. It just gives us 2 points, and we need to just substitute them into the distance formula. I would label them. So we have x1, y1, and x2, y2. You could have these switched if you wanted to, as long as you keep your x1 with your y1 and your x2 with your y2. So the distance is equal to the quantity, we'll do x2 minus x1, so 10 minus 1 squared, plus y2 minus y1, 1 minus 6 quantity squared. And now we just have to go ahead and simplify. Usually students make their mistake simplifying. They don't make their mistake substituting in. I would also encourage you to understand how to simplify these without just trying to punch it in the calculator. Because if you try to punch something like this right into the calculator, right, there's a lot of ways you can make mistakes. If you forget a parentheses, if you forget a square, if you forget the square root, if you put something outside the square root, there's a lot of ways to make a mistake. So I think it's always good to try to do these by hand as well. So that's going to give me 9 squared plus, in parentheses, negative 5 squared. If you don't put the parentheses, you're going to mess it up later on. So I get the distance is equal to the square root of 81 plus positive 25. Again, that's where the mistake would come in. If you just did negative 5 squared without the parentheses, it's going to give you negative 25, which is incorrect. So I get my distance is equal to the square root of 106. And it does say round to the nearest tenth here, so you don't have to worry about finding the exact answer. So the square root of 106 is approximately equal to 10.3. So that would be our final answer here, 10.3 approximately. Okay, again, my suggestion is you wait until the very end. You wait until this step to put it into the calculator. Again, I'm just speaking from experience. Students tend to, punch things incorrectly into the calculator, even when they would be able to do it by hand on their own. All right, let's clear this. I think we're actually going to skip number 7. That's one we'll either do in class, you can work on your own. You're just going to be applying the distance formula multiple times. I'm not going to say much more than that because I want you to think about why you'll be doing that. But you'll need to think about what perimeter means. You'll need to sketch a triangle, etc. So we're going to hold off on this one for the video, and we're going to move on to midpoint. All right, so there's a graph down here that you're going to use to answer these questions or to use while you think about the answers to these questions. I'm going to keep my screen down here, and then I'll just repeat the questions that are being asked. Before you continue with the video, please pause, work through as many of these questions as you can. Once you get stuck and you've exhausted your brain power, feel free to come back and join back in the discussion. This is the same type of idea as what we did up above. We're going to be deriving the midpoint formula. Now we're trying to figure out how do I find the exact center of 2 points. All right, so question number 1 says, sketch a point on AB that you think is exactly in the middle. So again, you just take a gander here. It looks something like that. Point looks like it's almost in the middle. Question number 2 says, your point may look like it's in the center, but that is not a valid explanation. Why is measuring with a ruler, or you could even say, or eyeballing it, not a 100% accurate method? Well, I think it's pretty clear that if you just eyeballed it, right, your eyeball may find the center or think that the center is different than somebody else who's trying to find the center, right? Even though you're both going to be in the same general vicinity, right, you could be off. Even if you're off by, 1/1,000,000th of a millimeter, well, those are still 2 different answers. So eyeballing it's not the best way to find the exact center. A ruler is a slightly better way. The problem is, though, even all rulers are not 100% the same. This is kind of a little bit off topic, but when you have machines in a factory creating devices or creating things like rulers or even clothes or other machines, they have a small margin of error. So even though, let's just take the ruler example, if one factory creates 1,000 rulers, even the rulers within that factory may not be 100% the same. Again, there may be a very small margin for error, right? And even though to the naked eye, no one can pick apart the differences in the rulers, they still may be there. Again, if one ruler is different from the other one, if the tick marks on one ruler are different by, let's say 1/1,000,000th of a millimeter, you're not going to be able to tell with your own eyes that those are different. But if we, had a machine determine that, or if we actually knew the precise location of where those tick marks should be, well, we could say that they may be off. So while rulers are good, they're not 100%, they're not going to be 100% exact. We need a formula that will give us that exact answer every single time. And that's going to be our goal for this section, is how to derive a formula, just like we did with the distance formula, that will give us the middle of a segment every single time. Number 3, Are there any types of segments on a coordinate plane that are easy to find the middle of, that you could be sure that you found the middle? Well, just like with our last example, it was easy to find the distance or the lengths of horizontal and vertical segments. It's the same when we're talking about the middle, right? If I draw a coordinate plane and I look at a perfectly horizontal segment, okay, I could figure out the exact number that's halfway between 1 and 9, right? Turns out that number's 5 because there's 4 units from 1 to 5 and exactly 4 units from 5 to 9, right? I was only working in one dimension, so it'd be easy to find the middle or the midpoint. Same thing with vertical segments, right? Let's say I'm at 3 and we'll do 11. Well, the middle of 3 and 11 ends up being 7, right? Again, there's 4 units between 3 and 7 and 4 units between 7 and 11. So we could easily find the middle there. The problem is when we get a diagonal segment or one that's not horizontal or vertical, because now we have to work with both x's and y's. But if we can somehow use the horizontal and the vertical pieces, maybe there's a way we could come up with an equation for a diagonal one or one that's on an angle. So number 4 says, try drawing a right triangle on the coordinate plane below where AB ends up being the hypotenuse. All right. You could either draw your triangle above this segment or you could draw it below. I'm going to go with the below option. There's our right angle. It says label the other vertex as C. So now we have triangle A, B, and C. Number 5 asks, can we easily find the middle of the 2 new segments that we drew, so BC and AC? So if you haven't already, go ahead, try to find the middle of those 2. One's a horizontal segment, one's a vertical segment, and we just talked about how we could try to find the midpoints of those. Well, the midpoint here, labeling in green, and the other midpoint we'd have up here, also labeling that in green. So we'll label these coordinates. This one is 7, 2, and this one up here, this one up here is 10, 7. So is there a way for us to use those 2 green points to figure out the midpoint of segment AB, the one that we initially wanted to work with, this segment right here? And we kind of already picked a point out there in pink that we thought was the middle, but could we use those 2 green points to confirm that? Well, if we look at what happens, right, if we go up until we hit segment AB, and if we go over until we hit segment AB, they intersect at the same point on segment AB. And this point ends up being 7, 7. And if you take a look at these x-coordinates, right, the x-coordinate for this green point down here was 7, and the x-coordinate of our new point, we're going to call that D, because that's the midpoint, is 7. The y value of our vertical segment was 7, and the y value of our midpoint was also 7. So we could just find, this would work every single time, right? If we had a segment, if we drew a right triangle around it, we found the midpoints of the horizontal segments, the midpoints of the vertical segments, and then just took the x-coordinate from the horizontal segment. So took the x-coordinate from this segment. That is going to be the x-coordinate of our midpoint. And we could take the y-coordinate of the midpoint of our vertical segment, and that would become the y-coordinate of our actual midpoint. The problem is we don't want to have to draw this diagram out every single time, right? It's a lot of work. It can be time consuming. We'd like to come up with just a formula. So let me get rid of some of this stuff. I'm going to get rid of everything except for the segment and what we know to be the points. And then I'm actually going to label point B, which is at 4, 2, and point A, which is at 10, 12. So now let's think about this. If I only use the 2 points I was initially given, is there a way for me to do something with my 2 x-coordinates to get the x-coordinate of my midpoint, right? 10 and 4. Is there any operations I can perform between 10 and 4, or maybe a series of operations that will give me the x-coordinate of D, the midpoint? Then we want to think about the same thing, but for our y's. Is there something I can do with my y values of my 2 endpoints to figure out the y value of my midpoint? So if you haven't already thought about that, go ahead and think about that now. Pause the video, take some time to run through some thoughts. All right, so if I'm looking at the x-coordinate of D and trying to get 7 from 10 and 4, well, if I subtract 4 from 10, I get 6. So that's not going to work. If I multiply them, I get 40. If I add them, I get 14. But 14 has a relationship with 7, right? If I divide 14 by 2, I'm going to get 7. So let's think about that. 10 plus 4 divided by 2 is going to give me 7. And that works. That gives me the x-coordinate. Now let's see if the same process works for my y-coordinate. Oops. Just realized I made a mistake there. This was 10, 12, not 10, 2. Hopefully I said it correctly. I just wrote it incorrectly. So I'm working with 12 and 2. So 12 plus 2 divided by 2. Well, that gives me 14 divided by 2 as well, which gives me 7. So we found and I know we've only done one example, but we have found a algorithm or an expression that will always give us the x and y coordinates of our actual midpoint. And this will work every single time. All right, I know we've just done it for one example, but this is something we can generalize to all segments if we follow this formula. So the midpoint formula, with no further ado, the midpoint is going to be equal to x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. If you add the 2 y coordinates together and divide by 2, that'll give you the y value of your midpoint. And if you add the 2 x values and divide by 2, you will get the x value of your midpoint. Let's put this into action, then we're going to wrap up this video. We're going to do 2 problems, number 1 and number 5. So if you want to pause the video, you can work through those and then come back and join us. All right, for number 1, make sure you label x1, y1. It's a little confusing. Let's make this a little bigger. There we go. So I've got x1, comma y1, and x2, comma y2. Again, it doesn't matter if you label those differently as long as you keep your x1 and your y1 together. So my midpoint, the coordinates of my midpoint are going to be equal to negative 10 plus negative 8 divided by 2. Not equals, but and negative 3 plus 4 divided by 2. And now I just need to simplify. Negative 10 plus negative 8 gives me negative 18 divided by 2. Negative 3 plus 4 is 1 divided by 2. So that's going to give me negative 9 and 1/2. These are the coordinates. I know I'm writing it big and I'm taking up space for 2, but just writing it big so you guys can see it more easily. The midpoint would be negative 9 and 1/2 if we're talking about those 2 points for number 1. So pretty straightforward. Let's move down and talk about a slightly tougher example though. So the directions here say find the other endpoint of the line segment with the given endpoint and midpoint. So up here, they gave us 2 endpoints, right? They said negative 10, negative 3, and negative 8, 4 were 2 endpoints. Here, they're giving us one of the endpoints, and they're giving us the midpoint, and we have to figure out what the other endpoint is. So we're solving for something different. Let me just draw a quick diagram for us so that we understand what's going on. So this endpoint is -2, -4. This other endpoint we'll just call x1, y1 because we don't know what it is. What we do know is that the midpoint is 7, 5. So we have to figure, I know that's not exactly what it might look like on a coordinate plane. I'm just giving us a sketch. We have to now solve our equation for x1. So let me show you something that we can do. Here's our regular equation, right? The midpoint xy is equal to x1 plus x2 divided by 2, or all over 2 rather, and y1 plus y2, oops, it's too large of a 2. Y1 plus y2 all over 2. We could break this up though and say that our x-coordinate of the midpoint is equal to x1 plus x2 divided by 2. And our y-coordinate is equal to y1 plus y2 divided by 2. Sometimes it helps to break these apart, especially when you're given a problem like this. So I need to solve for x1. Because this point right here, that's our midpoint, well, these two values represent x and y, and these two values down here represent x2 and y2. You could say that those were x1 and y1, and then you could make these up here x2 and y2. It doesn't matter, as long as you know that your x and y represent the midpoint, and your x1, your x2, y1, y2, those four coordinates represent the endpoints. So here I'm just going to substitute in. So for my x values, I know that my x value of the midpoint is 7. My x1, I don't know. My x2, I know is -2. All over 2. I'm going to keep doing this horizontally. So I get 7. Well, actually, let me just show you what we're doing. We're going to multiply both sides by 2. So I get 14 is equal to, these two simplify, x1 minus 2. And then I get 16 is equal to x1. So I just added 2 to both sides. If I come down here, I know that my y value for the midpoint is 5. I don't know what my y1 is. I know that my y2, though, is -4. And that's all going to be over 2. Well, I'm going to do the same thing. I'm going to multiply both sides by 2. That's going to give me 10 is equal to, those two simplify, I get y1 minus 4. And then if I add 4 to both sides, I'm going to get 14 is equal to y1. So remember that these two coordinates represented our other endpoint. So our other endpoint, and again, we're not worried about number 6 right now. None of this work is for that. Our other endpoint is located at 16, 14. So it does become a little bit more difficult when they give you the midpoint and one of the endpoints rather than just giving you the two endpoints. But it just changes what our unknown is in our equation, and we have to solve for something different. All right, that's going to wrap it up for today's lesson. As always, enjoy the rest of your day, and I look forward to seeing you at our next lesson.